diagram, you have this outermost category, and then if you have an oval inside, then it still has the qualities of the outermost category, and then adds a little more specifics to have a more specific category. Just like my cat, she's an animal, but she's a mammal, she's a feline, she's a house cat. First of all, we want to say that everything we're looking at here, all these different examples are quadrilaterals. These are all quadrilaterals. They're polygons with 4 sides and 4 angles that add up to 360 degrees. Every single quadrilateral has this quality. It includes irregular quadrilaterals, it includes concave quadrilaterals as well as convex, and then it includes quadrilaterals that can be classified more specifically, and that's why they're in those other ovals and circles. Who thinks they know what all of these types, let's look at the oval to the right here. Who thinks they can tell us what all of those types of quadrilaterals would be called?
Irregular?
They are irregular, but then these would also fall into there. So they have to have something else more specific in common.
Trapezoids?
These are trapezoids. Now, this one might throw some people, or even this one, because the trapezoid has to have one pair of parallel sides, but it doesn't have to be one on the bottom and one on the top. It could be held sideways, it could be held, slanted. So the trapezoid, the thing about it is that it has one pair of parallel sides. And my memory stinks, and you know this. So to try to remember it, there's a scene of a science fiction movie, one of the Star Wars movies, where they're trapped in like this giant trash compactor.
Oh yeah,
They're trapped,
yeah.
and the walls start coming in and going to crush them. So that's what I think of for trapezoid. I look at all the ways I could look at the shape. So does it have like a floor and a ceiling with the walls slanting in on them? So that's a trapezoid. Or it could be just one of the walls. It doesn't have to be both of them. So this one here, it's got these are the 2 sides that are parallel. So therefore this is the wall that's slanting in. This one I think has these 2, and this one has these 2. These 2 down at the bottom are specifically isosceles trapezoids. If they had continued up, they would make an isosceles triangle. These angles, these base angles are congruent, that sort of thing. But, so trapezoid, 1 pair of parallel sides. Down here I just added this, so go ahead and draw this in your notes. Draw a circle. And who can tell me what they think this shape is called? This is not a rhombus. These sides are congruent, but these sides are not congruent. So these are kites, yeah. So down here I just added a new category. Let's call it kites. And the thing with kites is that adjacent sides are congruent. So that was newly added, so that we try to draw in a circle or an oval down there for kites. And note that adjacent sides are congruent. And try to draw a picture where you notice that the sides that are next to each other are the ones congruent. They're not congruent to the other. So they have a set of short sides and a set of longer sides. So kites is new. And then we can focus on this big subcategory over here. There's lots of different examples inside here. So we got these, those, that, and then down there. So we have 1, 2, 3, 4, 5, 6, 7, 8 shapes in our diagram that all fit into this specific category. Who thinks they know what category we're looking at here? No, these are not rectangles here and here, nor are these ones down there. Parallelograms. So these are all parallelograms in here. The thing you need to notice about parallelograms is that opposite sides are parallel and congruent. And it also holds true that the opposite angles congruent. So then under the parallelograms, we have a couple of different specific types of parallelograms we could analyze. We have these ones here, inside this upper circle. We've got these two that are a little bit longer, and these two that are exactly the same in every side, same length on every side. So what are all of these called?
Rectangles.
These are our rectangles. So notice these squares are inside the rectangles because the square is just a specific type of rectangle. So when my daughter is doing her little Sesame Street shapes book, it has 4 right angles, then it's a rectangle. So it says find all the rectangles on this page. So she finds all the traditional oblong rectangles, these type. And then I go, no, but there's more. No, Mommy, those are squares. No, sweetie, those are actually rectangles, because to be a rectangle, you have to have 4 right angles. You see the corners, and see how the corners are the same as the corners of those ones, and so on. So yeah, so the squares are a certain type of rectangle. Your traditional rectangle that people commonly think of, you could call them oblong rectangles to differentiate them from the squares that are rectangles. What about down here, this bottom circle, where we've got these diamonds according to my son's little, iPhone app where he's supposed to find the shape and point at the shape. Find that diamond, and Mommy sits there and goes back on going, no, it's not diamonds. What do I call it?
Square.
No, these ones down here. Squares don't get slanty like that.
Rhombus.
Yep, these are the rhombuses. So it'll go, find the diamond, and I'll go, no, find the, and as it's saying diamond, I go, rhombus. Find the rhombus. So, poor kids tortured. Okay, so the plural would be rhombuses or rhombi. So since they call them diamonds, and diamonds are sparkly like stars, we could say it's like Dancing with the Stars, the rhomba. Anyway, we just kind of came up with that early thing. The rhombus is a parallelogram, it fits in that category, but with 4 congruent sides. So the rhombus is a parallelogram with 4 congruent sides. Now sometimes the rhombus has right angles, like these ones. Sometimes your rectangles have 4 congruent sides, like those ones. So that's our overlapping category. And those would be called what? Yes, ma'am.
Squares.
Those are our squares. So they have the 4 right angles and 4 congruent sides, which is redundant. I don't even have to write that because it's already implied by being part of the rectangles group and being part of the rhombuses group.